Git and GitHub do not work well together. That might sound like a stupid thing to say. Git is literally in GitHub's name. But what I've discovered is that these two pieces of software have fundamentally different ideas about how we should collaborate when writing code, which sometimes causes weird and confusing behavior in GitHub. GitHub's core features are hosting Git, adding restrictions, usually in the form of branch protection, code review, connecting to CI/CD, and if you have a poly repo, organizational search. But if you've been programming for any amount of time, you may have realized that Git and GitHub are sometimes at odds with each other when it comes to these core features. And that's because Git isn't really designed to be used this way. That usually manifests itself in different competing practices that use the same tool for the same job, but in different ways. If that's a bit confusing, let me share a couple examples. Should you branch off the root repository or fork? How long should branches live for? How do you handle dangling branches after merging? What parts of CI run pre-commit or when the branch is pushed? Should you rebase, squash, or merge? Why does it even matter? What should the main branch commit name be when a PR has multiple commits? There's also some deeper issues, like why do we need merge queues, and why do mono repos never scale quite right? But what I think is the biggest misalignment of all is that we've been moving everything to GitOps, but the discussions around changes still live outside the Git history. We've moved our infrastructure, deployment pipelines, documentation, and whatever else we can to be tracked in version control. And that usually gets picked up by GitHub to run a pipeline or show a README. But we still can't get the discussion around every change to be tracked with the code. These discussions provide crucial context for the project, but we can't access them without a proprietary auxiliary tool. A tool that isn't very good at showing complex discussions anyway. These long threads in GitHub are terrible. I hate email as much as the next guy, but I would still probably pick it over this. My hot take for this video is that all the core features provided by GitHub should be included directly in the version control system. And in some ways, they actually are, just not for your use case. And that's because Git wasn't built for you. It was built for one thing, and that is to maintain the Linux kernel. We've shoehorned it into every software development project since then, and it might still be the best tool for the job, but that is not what it was originally designed for. GitHub solves whatever problems we encountered when we tried to force Git into every project. But people were writing code before GitHub. And even today, do you think you can just branch off the Linux kernel and raise a pull request? Raise a pull request. They'll laugh you out the door. A pull request. What are you, some pathetic Gen Z developer? So how do they raise changes on the Linux kernel? I don't know. I'm a pathetic Gen Z developer. Let's say that I have a code base I want to share with the world. I'll use this poker server I wrote that I couldn't use in a video because I have no storytelling skills as an example. Git already comes with all the tools you need to collaborate with other developers. The first step is hosting the repository on a server. I'm going to do this on a Raspberry Pi to show that it can be done on an external server. If you're just going to push and pull to a private repository using SSH, then this is as simple as creating a new bare repository and adding your SSH key to that server. Git just works flawlessly, using the URL of the box and the file path of the repository. I can add a new remote and then run all Git operations like I normally would. I can also make my repository viewable in the browser and accessible for anyone over HTTP using Apache. To do this, we need to install Apache and GitWeb. This works better if all your public repositories are in a common folder. I'll enable a couple Apache modules, disable the default Apache site, and then create a new site with the following config. This bit tells Apache where GitWeb is running and sets a couple environment variables. This bit uses what Git calls smart HTTP to allow Git operations to run over HTTP. And then this bit is for authentication. If you want to allow everyone to read and write, then you can just delete it. If you want to restrict all reads and writes, then you can just add this bit to the /git location. I want to allow reads but restrict writes. So I set an environment variable if I detect git receive pack in the URL, and then check for authentication only when that environment variable is set. You can use whatever Apache authentication you like. This is just using a username and password stored in a file on the server. This whole approach is kind of hacky, but it's the easiest way to differentiate between reads and writes in the Apache server. It does mean I'll have to enable the receive packs config in my repository though. While I'm here, I'll also deny non-fast forward pushes, which stops contributors from rewriting published history. And don't forget to enable the new Apache site. I also need to update the GitWeb config file to point to the folder that stores all my repositories. Okay, that bit was a bit more complicated, but it's still relatively straightforward, especially if you're familiar with Apache, which I'm not. And it's very nice to be able to browse the Git repository. I can see all the commits and the current tree all from within my browser. I can also clone and push, both using HTTP or SSH. Git at its core is a distributed system. It's the third word used to describe it on their homepage, after free and open source. And this is how it was originally meant to be shared. Pushing and pulling between multiple computers, everyone keeps a copy. It's kind of weird that I only ever have one remote these days. 2 at most if I'm pushing from a fork. This feature is what makes Git so scalable and reliable, but we barely ever use it since everything is just pushed to one place. Now let's say you're a nice guy, and you stumble across my codebase and want to suggest some changes. You're not going to make a branch. You don't even have permissions to do that. The traditional way to do this is to create an entity that just contains the changes. This is called a patch. And it's basically what GitHub makes a branch look like when you open a PR. Let's say you see my poker server and you think that Texas Hold'em is lame. You want to add Omaha High-Low. All you have to do is clone my repository and make your changes locally. I just had an LLM cook up Omaha High-Low, I don't even know if it works. And then you create a patch file. You can create a patch file from a specific commit by running git format patch with the hash. Or you could write a patch for the last n commits by running this command. This will create one patch file per commit. The patch file represents an atomic change that you can share with the maintainer wherever you like. This is part of what keeps Git distributed. Isn't it kind of stupid how we raise a change on GitHub and then immediately post a link to it on Slack because GitHub's notifications are terrible? And then some of the conversation happens in the PR, but if someone takes too long to reply, you continue the conversation in the Slack comments. And now the conversation is in 2 places and neither of them are tracked anywhere? Yeah, well, this whole approach, the way that Git was intended to be used, cuts out that middleman entirely. You just share your changes directly, in Slack, or in an archivable mailing list, or wherever makes most sense to you. Patches do a better job at representing the actual changes. Instead, what we usually use is a completely different fork or branch, and GitHub resolves the differences from that. But even more than just the distributedness and simplicity of patches, there actually are some really strong workflow advantages that I miss when using GitHub. Once you have a patch file, it's just as easy to read it as it is to apply it on your local repository. Both of them are just one CLI command, which reduces the friction to actually applying the changes locally, viewing them in the context of the whole codebase with the tooling you have set up on your computer. You could still do this when using GitHub, but the extra friction of fetching someone else's branch, or sometimes even adding someone else's fork as a remote, usually means that people don't do this. Which is sad, because I do think that this makes for a better workflow. I would love version control tooling to make it as easy as possible to review changes directly from your editor. I think it results in higher code quality in the long run. This whole workflow addresses many of the debates that happen with the current GitHub workflow. Branches versus forks stops being a question. Contributors don't even have server-side access at all. The whole rebase, squash, merge conflict becomes the maintainer's private decision instead of a team-wide policy. And server-side branches go back to meaning something. Long-lived representations of different project states, not just temporary containers for individual changes. When it comes to build pipelines and artifacts though, Git definitely has no advantages. Git was designed to be distributed, so there's no central computer that can run pipelines and generate artifacts. That responsibility falls to the maintainers. Whomever is hosting the Git instance can run whatever scripts they like to generate artifacts and then host them on a server somewhere. That being said, since the kernel is so distributed and open, they still find a way to run continuous integration through distributed systems. There are multiple systems that will pull the Git trees and patches included in public mailing lists and run continuous integration to catch issues as early as possible. So quick summary, you have a Git repository and you host it on one or many servers. You use Apache or SSH for authentication and configure the repository using git config. Contributors can suggest changes by sending you a patch file, which you apply locally and then push to your remote tree. You also run tests locally on your machine or have a third-party server that polls and runs them for you. Then either you or that third-party server pushes artifacts to a server. Based on all this, I'm going to make an observation that I'm sure has already been made, but has never occurred to me before. If you've been paying attention, you may have noticed that Git's identity is all about being distributed. This is what it was designed to do. That is how it works and why it served the Linux kernel so well. But in the process of making the source code distributed, it has made the maintaining be very centralized. And this is why Git never quite agrees with GitHub, and why we need GitHub in the first place. So using the Git workflow gives you a distributed codebase that revolves around a central set of owners, while using the GitHub workflow gives you a centralized codebase, but with distributed ownership. Let me explain what I mean by that. When you raise a change using the Git workflow, it has to be approved, merged, and pushed by one of the core maintainers of the project. If they are sick or away or retired, then you need to appoint a new person to fulfill those roles. GitHub allows you to implement rules so that any two people at the company can merge changes together and run a CI pipeline as a result. GitHub can do this because the code is on a centralized server. And this is much more appealing for businesses. You don't want the code ownership to be tied to any one person, but in the process, you become tied to one private entity. The GitHub workflow is undeniably better for most people. And that's why I said that even though Git does include all the tools you need to collaborate in its ecosystem, those solutions aren't really for you. They're for the Linux kernel. I think the truth is that the GitHub workflow makes the best of the current situation. Look, I'm sorry. I would love to tell you to delete GitHub and go back to sending patches, but that's just not really better for most people. But next time you see people arguing about rebasing or squashing or branching or forking, remember these oddities exist because Git and GitHub were designed with fundamentally different ideas about how code and ownership should be distributed. Once you see that, a lot of GitHub's weird behavior stops feeling random and starts making sense.